Welcome to the series titled AWS Regions and Availability Zones, How to Architect with the Design for Failure approach. In this course, we will walk through just one of the many how-tos aimed at building a flexible, available, and highly resilient application in the Amazon Web Services environment. To get the most out of this series, it is recommended that you have a basic understanding of AWS. Let's get started. But before we get into our high availability goals in application architecture, we need to get level on our terminology. As of this recording, there are 10 AWS regions, 8 of which are available to the general public, one that is limited to government agencies in the United States, and another that is in limited preview. A region is a geographically separate location which hosts multiple availability zones. Pricing in AWS is based on the region you choose. Choosing a region is an important decision that should be based off of factors relevant to your AWS usage. Typically, this will be in a region where the majority of your user base will be located. Within each region, there are distinct data centers known as availability zones. Availability zones in the same region can share AWS resources such as databases, snapshots, queues, and more. Because availability zones within the same region can share resources, it makes designing for high availability within a region pretty easy. It is important to note that an availability zone can become too congested for more resources to be launched. When AWS locks down an availability zone, new accounts in the region do not have an option to select that zone, and existing customers will be prevented from launching new resources. Because of this possibility, we will need to ensure our applications are not availability zone dependent. A virtual private cloud, or VPC for short, is a logically isolated section of AWS. This is your network in the cloud that you have full control over. You launch and configure resources within a VPC. It is important to note that VPCs can span availability zones but not regions. VPCs are one of the AWS services that can be used free of charge. RDS, or Relational Database Service, is a service that makes it easy to create and manage database instances. It strips away the typical database administrative task by handling the backups using a backup schedule you choose and a maintenance window you specify. For most database engines, high availability is already baked in, making it a no-brainer for many organizations that do not have an on-site DBA. Currently, RDS supports a variety of database engines such as MySQL and Microsoft SQL Server, to name just two. CloudFront is AWS's content delivery network designed to speed up requests for end users. This is accomplished through a series of origin and edge locations scattered around the world. Content can be pulled from EC2 instances, S3 buckets, and custom resources. CloudFront can be used to cache static and dynamic content for a specific amount of time. AutoScaling is a service that adjusts the number of application instances based on min-max desired values and/or application load. For example, you can configure a new instance of your application to be created when the CPU load of your instances sustain 80% utilization over a 5-minute period, or terminate an instance when the same CPU is running at 30% utilization or lower over a 20-minute period. The goal of autoscaling is to reduce human intervention while providing the most cost-effective and best user experience possible. It is one of the AWS services that does not cost extra. You only pay for the resources launched by autoscaling. Simply put, Route 53 is a domain name service. It offers many high availability features such as latency-based routing, health checks, and failover policies. Our high availability design goal for this series is 5 nines of availability. That is roughly 5.5 minutes of downtime per year. It is considered the gold standard of high availability applications. In order to hit our 5 nines goal, we need to design a self-healing architecture, build a fault-tolerant infrastructure, eliminate all single points of failure, and provide a graceful degradation of services during outages. This can be accomplished with many of the AWS service offerings. We have some challenges we have to identify before we begin. These challenges center around moving our high availability design to multiple regions. When initiated, services are scoped for the region they are launched within. What may be incredibly simple to configure and use within a single region can quickly turn into a headache when spanning multiple regions. This will most likely force changes to the hosted application. Adding to the complexity is that some services are not available in all regions. At the time of this recording, Simple Email Service, or SES for short, is available in US East 1, but not in US West 1. Obviously, that is quite the conundrum. Do you use a different service? Maybe you use a VPN to access the other region's SES. Or maybe you select some other approach entirely. Therefore, it is extremely important to be aware of regional limitations when making design decisions. Latency and data synchronization pose their own sets of challenges. When data has to be shared across regions, it suffers from delays as it traverses continents and oceans. A newly inserted record that is immediately available in the US East region may not be seen for some time in the Singapore region. Therefore, an application's data access routines have to be designed with an intelligent read-write methodology in mind. There's no single right way to do this. It depends on the complexity and goals of the individual application. Our sample application will offer just one possible solution to this dilemma. Let's take a look at the application. Our application will be the sample from a great book called Rails Tutorial by Michael Hartle. It is a simple Twitter-like application built in Ruby on Rails 4. It runs in a Linux environment using MySQL as its data store. Without tweaking the application, we will leverage the built-in power of AWS to create a highly available system. Our architecture will look like this. This architecture diagram shows a pretty standard high availability design for web applications. Users will direct their browser to our URL. CloudFront will deliver the user a cached version of the object requested. If this does not exist, the request will be forwarded to the Elastic Load Balancer in our US East 1 region's subnets. If US East 1 is unavailable, CloudFront will fall back to the EU West 1 region. Regardless of the region, the Elastic Load Balancer will direct traffic to one of the availability zones. Our Web EC2 instance will build the response using RDS if the request involves a database store. When the response works its way back out, CloudFront will cache the response for the next request to the same URL. Lessons in this series will call back to this diagram as needed to show what we are targeting. A few notes before we start building our solution. We are not going to go over security best practices in this series. That will be demonstrated in a different series. However, we have not skipped security in building our environment. We are just not showing all of the steps necessary. Remember, the security of your account and your applications running within it are very important and should not be taken lightly. We are selecting the low-cost, slow configuration options. In a true production environment, we would not select T1 micro instances for our RDS instance. Our focus is on high availability. We have pre-built and configured our AMI to save on time. This is just one of many possible high availability scenarios. AWS has an architecture blog that shows different scenarios for different uses. The concepts we go over in this series are the same regardless of our design decisions. Everything we are doing is from the AWS console. You can also do this from the AWS command line interface. Lastly, we could use Elastic Beanstalk or OpsWorks to get us most of the way to a high availability solution. While this is great to have, we believe it's important to build from scratch to facilitate an understanding of the core concepts. Now that we have introduced you to the series, let's build our solution. On to the next lesson, building our VPC environment.